So, are you ready for the real action? And this is part 8 of Code Your First extension tutorial. So, where do we start? First of all, CopperCube, as any piece of software, has its own documentation, which is really great because everything should be documented. Inside documentation section, let's just go straight forward to scripting and you can just read through it. I've already done that. I know that thing that you need to do is just need to click on this create a scripted behavior using JavaScript. And here you have an example, and also you have a description where do you need to put your extensions in order for them to work. So since I'm on Windows, it will be this folder, Documents, CopperCube Extensions. Basically, I need to navigate there. Here I have this folder, and you drag and drop this folder to Visual Studio Code, and now the folder is open for you. As you can see, there are multiple default behaviors which you can modify, which you can use to educate yourself. And I also have a couple of other files here in our folders, which is steps, which contains the whole declaration of all functions for CopperCube. I use this in order to enable autocomplete for CopperCube functions in Visual Studio Code, and I will probably just provide these files in the zip in the description. So first of all, we have our folder opened, we have our CopperCube opened. Let's just create a new project. And the extension what we are going to be doing is a simple move extension. So we will just move our character on the ground. It will go towards the way the character is looking, and it can rotate clockwise, counterclockwise, and also move forward and backwards. So let's create a new folder for the project. Let's call it simple movement, and I'm just gonna save the file there. It's already in simple movements for some reason, and I'm just gonna call it SM CCB. And now, very first thing is let's just set up our scene. I will remove the default cube. We'll add the plane. I will make width and length of it a bit higher. I will also set its position to 0, so it starts on 0 coordinate. And let's just add some prefab man. This one, it has like nice pants. I hope I will find such pants somewhere at some point because they look really great. And we will also set this guy in the 0 position, the 0 coordinate. It's much easier to work with objects which are at 0 position for me. So then let's set up the camera for him. We will use the third person camera. We will specify the sleepwalker guy here. And you guessed it, we set up 0 position for camera. Now let's move camera in its position that it's supposed to be. So now it's behind its back, his back. And also in behavior, let's modify this target height to something like, no, it's too high, to something like 6, I guess. So it looks up his shoulders. I think it's great. And the very last thing which we need to do is we need to add a behavior which is called collide and moved to our character, and we also need to set up size properly. As I've done with characters multiple times, I mean, not I've done them, but I mean, you got the idea. If I've done examples like prototypes with these characters, I know the values. It will be 4, 9, 4, and minus 9 on the y-axis. So now we have everything set up, and basically our character is also controlled by gravity, which is great. And let's for a second think about what actually we're going to do. We need to move this guy on the map. It can move, not it. I mean, this is a guy in nice pants. He can move forwards. And if he moves forwards, everything's pretty simple. Basically, we have the coordinate here, the position, and we need to modify the z position on every frame. If he faces like 90 degrees, it's also pretty straightforward. We just modify the x position, and that's it. But what if, for example, this strange guy, for some reason, let's just say it to zero, set it to 0 again, just rotates for some degree like 35? Like, how do we understand uh, where do we move him? Like, how do we move him for on both axes? Basically, we have this guy's speed, or we have a distance which he should cover every frame. And with z-axis, it's simple. So you just move him like 30 units this way in frame, or 30 units this way. And in order to figure that out, I mean, in order to figure out how we should move him in case we have rotation not 0 and not 90 degree, we should use mathematics. Yes, that's right. For all you people who said, it's only in school, I won't need mathematics in real life. You are now officially, screwed. This is what happens to people who don't learn mathematics in school. So basically, you have the coordinate, the z coordinate here, and x coordinate. Y coordinate is pointing at you. We don't need it since we won't do any vertical movement for our guy. And in case of z, we have this distance. Let's say it's d. In case it's rotated to 90 degrees, we have the same distance d here. And in case he has he need to move somewhere in between, we need to calculate uh, basically this value here and this value here. How we do it? Trigonometry. Um, let's just say this distance is the same as this distance, and now we have the triangle, and this angle is 90 degrees, right? So basically, this is a leg, this is a leg, and this is a hypotenuse. If we want to find the z coordinate in any time, what we need to do, just tell me if I'm wrong. I might be wrong because I always mess them up, but I believe what we need to do, since this is the opposite leg from our angle, we will have to use sinus for to define how. Oh, no, cosinus. It will be like cosinus. Yes, it will be cosinus because we need this distance. Okay, we will multiply distance to cosinus of this angle, and since this is the this one is the opposite, leg, we will use sinus of this angle in order to find this distance. Basically, it will be like dz. It will be cosinus multiplied by distance, cosinus alpha multiplied by distance, and we will have dx, which will be sinus alpha multiplied by distance. You get the idea. Basically, we need to use some math um, to set our person correctly in the map. And with all that knowledge, let's start coding. First of all, let's refer to documentation once again. So they say that inside this extension directory, you need to create a new behavior and name it behavior move between points.js. We will just name it the way we want. We need to keep this first behavior part, but the second part will be something that we will come up. So it will be behavior, and we will call it simple movement, and totally blank file. What what we can get from here is that there is extension declaration, which I will just copy. from the file, and it has some properties which I will remove for now. And if you're interested what they are, you can basically call ask ChatGPT, but it won't work. You need to read documentation. Now I changed the JS name to the same name as our file have, but without JS extension. And also I changed the description to some description which this line will appear in CopperCube editor when you choosing the behavior. So it should make at least some sense. The very next thing, as you can see from the documentation, what happens here, there is a class declaration here, and the class named the same way as our file is named. So it's also behavior move between points here, and for us it will be behavior simple movement, and then it will be function, and basically we can also do like that, so we understand that basically we have declaration and also initialization here. And I don't know why don't we have it here, but and in order for everything to work, we also need another function which is called on animate. Uh, it should be in every it should be in every like in every behavior. So it's called on every frame. If it doesn't exist, the behavior won't work. And I believe this is the bare minimum. So let's see if we can actually edit. So first thing we need to do is we go to edit, click on plugins, and click on reload and verify extensions and plugins. And here, what it will do, it will just verify all your extensions, and it say that here we have our behavior simple movement, and it says it's done with extensions. I have some plugins which cause the error, but I don't care right now because our extension is actually built. One next thing which we do, we just go to our behaviors of our sleepwalker guy and go to scripted behaviors, and here we have our simple movements. Yeah, we will just edit, and let's see if we have any errors. And as you can see, no errors here. So what this function does, as it was mentioned before, as I just mentioned, on animate is a function which is called every frame. So if we put something here, let's say we put print statement, which is sort of uncommon because before we were using console log, but console log doesn't work in CopperCube. You should use print instead. If you just put it here on every frame, we should see the statement here printed in the CopperCube console. And since I've already sort of put a command here, a specific CopperCube command, you might ask yourself, like, where do you actually get this command print from? And the answer is pretty simple. It's from documentation. So there is a CopperCube JavaScript reference here. It should be right here if you go from the menu, and it contains the description of all functions which are available in the editor and which is available from your behaviors and actions, so from the runtime. Let's start figuring out what we actually need, like how we make our guy move. We can go through this reference, and we will see that there are two functions which actually have which we are interested in. And the first one is the CCB get scene node property. So as the description suggests, it allows us to get some sort of like property from the scene node. And the thing with CopperCube is that you can't just directly access these like positions, rotations, scales, and stuff like that. Instead of this, you should use the function which I mentioned before. So this is get scene node property, and then you need to specify node. Node is an object which is pointing to your node in the real game. And how do you access it? let's just get back to documentation and let's check this page with behavior once again. As you can see, this behavior on animate, it actually receives two values, which is node and time ms, and uh, node and time ms. And this node is basically the node which we are looking to get. So we can pass it here, and we can also like get, for example, rotation of its node. And let's save it to variable road, and let's print road.y. So what it returns to you? It returns an object which is created from a class named vector3d. Vector3d has some. This is basically a class to define a 3D vector. So it has like x, y, and z values, and it also contains some operations with which you can do with vectors, like adding, subtracting, getting length of the vector, and also normalize, I believe, these four. This is also defined in the documentation right here. So this is like vector3d class. And so if we do like that, we will see that now it will print us the value on which our guy is rotated by y-axis. So if we just put 39, let's say here, we will see that now it's 39. But I mean, it's boring. We just get the rotation. Like, how do we set it? To set the rotation, we use set synNode property variable function, and we will pass our node there as the first argument. Second argument would be rotation. It's the name of the property. Basically, these are the properties, and we are getting like these properties and setting these properties. And what we're gonna do is we're gonna modify this rotation slightly. So every frame, let's just add maybe like 2.5 degrees, and let's see what it will do. So now, as you can see, our guy is constantly rotating right or clockwise. So, I mean, it's not actually that fun because it does its thing itself, and we need to somehow capture user input. And for that, there is another function which we should add to the prototype, which is called onKeyEvent. I think it's called onKeyEvent or like that. I'm not sure. Let's just see how it's named in another behavior. So onKeyEvent. It's called onKeyEvent like that, and it will be function. And this function also receives two arguments. First of them is key, and second argument is pressed. So what are these? Let's just print key and then concatenated. You remember concatenation yet, right? With pressed value. So now if we just work to extension, and if we start pressing different keys on the keyboard, it will say us that some number, which is basically a key code of this keyboard, is either pressed or released. So second value corresponds to then the numbers, then the key is pressed and then it's released. If it's true, it means that the key is pressed. If it's false, it means the key is released. So we only need to do something if keys, no, we don't, no, my mistake. So how do we actually understand if our, like how we actually understand in which direction do we need to rotate our guy? Also pretty simple. We can modify this. We can just create another variable like rotation direction, set it to 0, and basically multiply our rotation to the direction. So if our direction is let's say -1, our guy will rotate counterclockwise. If it's 1, our guy will rotate clockwise. And basically, the value of this rotation direction will be defined by the keys which are currently pressed on the keyboard. In order to do everything right, we also need to define first two properties of this behavior simple movement class. First of all, first one we will call left is pressed, and we will set it to false, and the second one will be right is pressed, and we will also set it to false. So in case this left is pressed, we will take our rotation direction and we will decrement it. So basically we'll just do like this and decrement it by 1, and the same way as we've done it with addition, we can also do it with subtraction. So it's like minus equals and then 1. And in case let's not do else, let's just do if once again, if this right is pressed. So if we have right key is pressed on our keyboard, we will just add 1 to our rotation direction. And basically the very last thing which we need to do is we need to understand which keys are right and left on our keyboard. Let's just do it like the must. No, we won't do it. Let's just Google. So we just need to Google for JS key codes. Yeah. And here, let's just press left on the keyboard. It will say us that this is 37 and right is 39. So if key equals to 37, then it's our left. So we will set our this is left is pressed property equals to pressed. Basically, it means that if there is some event occurs with key 37, which is left on the keyboard, property of our class behavior simple movement left is pressed will be equal to either true if the left key is pressed or false if it's released. And also the same we will do with 39 with this right is pressed equals pressed, and that's it. That should work. Let's see if it's working. So now if I press right and left on the keyboard, our guy is rotating. That's great. So the next thing which you need to do, pretty much the same we're doing with position. So the first thing we need to do is we just need to get string node property. We pass node here, we pass position string here to get access to position property, and we will do like move direction variable, which is sort of the same. So we will define this is, oh, it's right. Okay, it's like up is pressed equals false, and then this down is pressed equals false. And let's just check what keys are for up and down. So it's 38 and 40. So if key equals to 38, which means that this up is pressed equals to pressed. And yeah, also if I didn't mention it in if video, but if you have only one statement in the block, in if block, you can put it actually without the block here. So it's the same as you're doing as you were writing your code like this. It's the same, but it works because it's only a single statement. So, and the very last thing is 40 here, and is down is pressed. We assign it to press. So now if this up is pressed, in this case we will increase move dir by 1, and if this down is pressed, we will decrease our move dir by 1 also. And now the thing is, here calculation was quite simple, but once again, the next thing which we need to do is we need to use this math thing which we discussed before in order to find the correct position. So we have two components of position which we need to modify. First of all is position .x, and we need to what we need to do is, first of all, what we need to do is we need to define some sort of speed. Let's just keep set speed. No, let's just do it right. Let's just make another property and call it speed. And let's say it's 0.3. I think it shouldn't be too fast. Will it? I don't know. Let's check. And this speed will be multiplied by sinus of root y angel. But the thing is that, as you can see, CopperCube uses Euler coordinates in degrees. So if you rotate it, it will be like 39. And JavaScript for calculation, it uses degree in radians. So we also need to cast degrees to radians. In order to do so, we just multiply it by pi, and we also divide by 180. And also here we're using another thing, which is math. Math is built-in class in JavaScript, and it contains multiple methods which you can use to do your math. Basically, in the tutorial, before we slightly touched floor or round. I'm not sure which one it was, but basically this is a class which contains a lot of different methods which can be used, and you can also call it from the class because these methods are static, and this is not something that we are gonna cover in this tutorial. Just remember that this is something that you can use, and it's multiplied by speed multiplied by this angel, and for z we also have the same, but now instead of sinus we should use cosinus, I think. And now let's just set node property to node for our node position, and we will say to value of variable pos. Yeah, I feel like I'm missing something, but I'm not sure what, so let's just see. Okay, so the guy is always working forwards, which is not something that we want. And why is this happening? Yeah, because we didn't multiply it to move direction. Yeah, I actually forgot to multiply it to move direction. So it's always zero. It was always zero, but I'm not sure why it worked like that. But I mean, so now finally we get the guy moving in the direction it's looking, and we can also rotate the guy. So here comes another issue. Let's quickly also do the following. Let's just also add rotation speed here, and we will use the property of rotation speed here now. Here comes another issue. Let's say, let's go to publish, and enable show frame rate, and also change the wanted frame counter to another value. And as you can see, now everything moves much faster when with 60 FPS. And if you set the FPS value to something low like 25, and you will see that everything is really slow, really slow. Why does it happen? It happens because this function is executed on every frame, which means that if you have different FPS values, it means that sometimes next frame is so the higher FPS you get, the faster next frame is being rendered. So basically, the game currently is, if you play it at 30 FPS, it's 2 times slower than if you play it on 60 FPS. And in order to avoid such behaviors, what people usually use is something called delta time. So delta time is difference between in time between current frame and the previous one. We can also calculate delta time in CopperCube using this time variable which we receive from onAnimate function call. And it's pretty simple thing to do. First of all, let's just define the last time variable here and set it to null. Null is also something that we didn't cover in the tutorial, but basically it means that property, in this case, of variable, if it was var last time, is defined, but its value is set to null. So it basically nothing. It means nothing. So in case this last time equals to null, in this case, what we're gonna do, we're gonna set last time equals to time, and we will also add a return statement here in order to stop the execution at this point, so we don't need to go further. We just in this frame we just set the last time. Next thing that we're gonna do is on the next frame we're calculating the delta time, or let's call it dt. In order to do so, we take our time in milliseconds and subtract our last time, so the time of the last frame, and this way we will get difference between them. And next thing that we do is this. Now this time, now this last time will be equals to time, to current time, because we're gonna use it in the next frame, so it should be updated every frame. And also something that is done in CopperCube, I'm not sure if it's actually relevant or not, but if dt is higher than 200, in this case, we will say that dt is actually 200. I'm not sure why that's done. I suppose it's then you, let's say you tabbed out from the game and then you return back, probably for these scenarios, I'm not sure. But this is quite a large interval. But I mean, at least this is something that they do in the official, so in the official behaviors. So I also do it a lot in every in every of my behavior. So the next thing that we need to do is now we need to use this dt in calculation of our rotation change and also in our speed. Basically what we do is we just multiply this change by dt, and we also need to adjust our speed a bit, so it's like something like that, and this is something like that, and this should not O3 I guess, and this way it should work. So now as you can see it moves much faster, he moves much faster, I mean, and if we set it to 60 fps, let's say, it still moves with the same speed no matter like what like FPS we have. So basically we didn't fall into a regular Ubisoft error issue. And the very last thing which we need to figure out is basically animation. So it's also pretty simple. So if our character is moving, we need to set animation to walk. And if it's standing, if he's standing, we need to set it to stand. You have a full animation list here, and we are interested in these two, walk and stand. Once again, we will be using our favorite setSynNode property, and here at the end, we will check if move direction is not equals to 0. So I mean, it means if the character is moving, then we will set a synNode property, the node animation to what? To walk. In the opposite case, we will just copy this line. We will set it to stand. And let's see how it works. Basically, as you can see now, our guy is moving and the animation is turned on. And if he's standing, we play stand animation. That's it. You can also improve this further because there is a thing, there is a property. Okay, on the wrong guy. There's a property called frames per second. So basically, you can set frames per second when the move direction is -1. You can set this property frames per second to negative value. So animation will be actually played backwards, and it will look like it won't look like he's moonwalking anymore. It will look more natural. But I mean, this is hard. This is an easy thing to modify, and you just feel free to do it yourself as a part of practice. Practice makes perfect. Practice is important. And at this point, I believe we have everything you need. Is it like 8th or 7th part? I think it was 8th part of the tutorial. And we got from basically from zero to hero. We learned JavaScript and learned how to program behaviors in CopperCube. Pretty neat, huh? All right, I think that's it for today. And I'm going to bed. To bed. See you next time.